Download this code from codegive.com, link in the description below. OK, let's delve into the presentation Zero-Cost Abstractions in Rust by Vitaly Bragilevsky, delivered at Rust Linz in November 2023. I'll provide a detailed explanation of the core concepts he likely covered, along with illustrative code examples. I don't have the exact slides, but I can reconstruct the content based on the topic and Vitaly's general style, focusing on key Rust features that enable zero-cost abstractions. Understanding zero-cost abstractions. The central idea behind zero-cost abstractions is that you can write high-level code using modern programming paradigms without incurring runtime performance penalties compared to writing equivalent code in a lower-level, less abstract manner, like C or C++. Rust achieves this by performing much of the heavy lifting at compile time, leveraging features like *ownership and borrowing * ensures memory safety and data race prevention at compile time, eliminating the need for garbage collection or manual memory management with associated runtime overhead. Generics and monomorphization * allows writing generic code that works with different types. The compiler creates specialized versions of the code for each specific type used, resulting in no runtime cost compared to writing separate, type-specific functions. Traits and trait objects * enables polymorphism, using objects of different types in a uniform way. Static dispatch, using generics and impl-trait, is preferred when possible because it avoids runtime virtual function calls. Dynamic dispatch, using trait objects, can incur some runtime overhead, but is sometimes necessary. Inline functions * the compiler can replace function calls with the actual function code directly, eliminating the overhead of function call and return. Compile time evaluation, const fn, const generics allows computations to be performed during compilation, further reducing runtime overhead. Macros * enable code generation at compile time, providing powerful ways to reduce boilerplate and create domain-specific languages. Data layout control, repair attribute you can precisely control how data is laid out in memory, allowing you to optimize for specific hardware or interoperability requirements. Key concepts and code examples. Let's examine how these Rust features contribute to zero-cost abstractions with specific examples. 1. Ownership and borrowing. Example * moving and borrowing data. Explanation Rust's ownership system ensures that each piece of data has a single owner. When the owner goes out of scope, the data is automatically deallocated. Process _string takes ownership of the string, and my _string is moved into the function. After process _string finishes, the string is dropped. String _length borrows a reference, end string, to the string. Borrowing allows you to use the data without taking ownership. Multiple immutable borrows are allowed, or a single mutable borrow. This strict borrowing system guarantees memory safety at compile time, without any runtime overhead like garbage collection. 2. Generics and monomorphization. Example generic function. Explanation add t is a generic function that works with any type t that implements the add trait. Monomorphization is the process where the compiler creates specialized versions of the add function for each type used, example add_i32, add_f64. This happens at compile time. The generated code is as efficient as if you had written separate add_i32 and add_f64 functions directly, avoiding runtime type checking or dynamic dispatch. No performance overhead is incurred due to the generic nature of the code. 3. Traits and static versus dynamic dispatch. Asterisk example asterisk trait with static and dynamic dispatch. Asterisk explanation asterisk. Asterisk speaker is a trait that defines a speak method. Asterisk dog and cat implement the speaker trait. Asterisk static dispatch, generics / impl trait make _ speak t, speaker uses generics. The compiler generates a specialized version of make _ speak for each type that implements speaker. This means the specific speak function to call is known at compile time, resulting in direct function calls, no overhead. This is zero cost. Asterisk dynamic dispatch, trait objects make _ speak _ dynamic takes a trait object and dyne speaker. A trait object is a pointer to an object that implements the trait, along with a Vitaly, virtual table. The Vitaly contains pointers to the actual methods of the object. The speak function to call is determined at runtime by looking up the function pointer in the Vitaly. This involves an indirection and introduces some runtime overhead. While not strictly zero cost, it provides flexibility. Rust encourages you to prefer static dispatch where possible. 4. Inline functions. Asterisk example asterisk inline function. Asterisk explanation asterisk. Asterisk the inline attribute is a hint to the compiler to replace the call to square with the actual code of the function directly at the call site. Asterisk this eliminates the overhead of a function call, setting up the stack frame, jumping to the function, returning, etc. Asterisk inlining is most effective for small, frequently called functions. The compiler makes the final decision about whether to inline based on various factors, function size, optimization settings, etc. 5. Compile time evaluation, const fn, const generics. Asterisk example asterisk const fn and const generics. Asterisk explanation asterisk. Asterisk const fn defines a function that can be evaluated at compile time. The factorial function calculates the factorial of a number. Asterisk const array _ size stores the result of factorial, 5, which is calculated during compilation. This value can then be used to define the size of an array, which must be known at compile time. Asterisk this moves computation from runtime to compile time, resulting in faster execution. 6. Macros. Asterisk example asterisk a simple macro. Asterisk explanation asterisk. Asterisk macro _ rules, defines a macro. Asterisk the macro create _ function, takes a function name as input, $func _ name ident. Asterisk the macro generates a function with the given name that prints a message. Asterisk macros enable code generation at compile time. They are used to reduce boilerplate, create domain-specific languages, and perform complex transformations on code. Macros themselves have no runtime overhead, the generated code does, of course, but it's as if you wrote it directly. 7. Data layout control, repair attribute. Asterisk example asterisk controlling struct layout. Asterisk explanation asterisk. Asterisk the repair attribute controls how data is laid out in memory. Asterisk repair, C, ensures that the struct's layout is compatible with C. This is important for interoperability with C code. The compiler may insert padding between fields to ensure correct alignment. Asterisk repair, packed, removes any padding between fields. This can reduce the size of the struct but may also affect performance if the data is not properly aligned. Using packed can improve memory usage but might make accesses slower due to alignment requirements of the target architecture. Asterisk controlling data layout can optimize memory usage, improve performance, especially for cache locality, and ensure compatibility with other languages. Important considerations ***. Benchmarking is key ***. While Rust aims for zero-cost abstractions, it's crucial to benchmark your code to verify that your optimizations are actually effective. Use tools like Cargo Bench to measure the performance of different approaches. Compiler optimization ***. The Rust compiler, especially when using release builds with Cargo Build Release, performs extensive optimizations, including inlining, loop unrolling, and dead code elimination. Trust the compiler to do its job, but always verify with benchmarks. Trade-offs Zero-cost abstractions don't always come for free in terms of development time or code complexity. Sometimes, a slightly less abstract approach may be simpler and more maintainable, even if it introduces a small performance overhead. Weigh the trade-offs carefully. Profile. Use profiling tools to identify the performance bottlenecks in your code. Then, focus your optimization efforts on the critical areas. Summary ***. Vitaly Bragilevsky's presentation at Rust Linz likely highlighted how Rust's design philosophy of zero-cost abstractions allows developers to write expressive, high-level code without sacrificing performance. By leveraging features like ownership, generics, traits, compile time evaluation, and precise data layout control, Rust enables you to build efficient and safe software. The key is to understand these features, apply them appropriately, and always benchmark your code to ensure that your optimizations are actually delivering the desired results. Remember to consider trade-offs between performance, code clarity, and maintainability.